Case study, Revolutionizing Network Security, Harnessing the Power of AI at Cybersecure Solutions. Artificial intelligence stands as a powerful tool to fortify network security against increasingly sophisticated cyber threats. In the boardroom of Cybersecure Solutions, a mid-sized enterprise specializing in cybersecurity services, CTO Emily Turner presents a new initiative to integrate AI into the company's existing network security framework. Her team, comprising data scientists, network engineers, and security analysts, has gathered to address the potential and pitfalls of this transformative technology. As Emily elaborates on the plan, she underscores that the core challenge lies in the acquisition of high-quality, voluminous data necessary for training AI models. Jason, a seasoned data scientist, interjects with a concern. How will they ensure the quality and quantity of data given the diverse and evolving nature of network environments? The group debates this, recognizing that while data from various sources could provide a robust training ground, privacy concerns and the heterogeneity of network environments could impede the collection of consistent and compliant data. To address this, the team proposes employing federated learning, a technique allowing AI models to train on decentralized data while maintaining data privacy. By leveraging federated learning, Cybersecure Solutions could harness data from different network environments without centralizing sensitive information. However, this approach raises another question. Will federated learning achieve the same level of accuracy as traditional centralized training methods? The team agrees on the necessity of an initial pilot study to validate this approach before full-scale implementation. As the discussion intensifies, another vital concern surfaces: the vulnerability of AI systems to adversarial attacks. Mark, a network engineer, presents a recent incident where an AI-based intrusion detection system failed due to manipulated network traffic patterns. This sparks a debate on how adversarial attacks could compromise AI systems and the measures required to fortify them. Emily suggests the development of more resilient models, incorporating adversarial training techniques. The team ponders on this. What additional safeguards could be implemented to protect AI models from adversarial threats? Jason proposes integrating robust AI frameworks that utilize gradient shielding methods, which obscure the gradients used in optimization algorithms, thus making it more challenging for adversaries to create deceptive inputs. They also consider employing ensemble learning, where multiple models work together to cross-verify predictions, enhancing the system's resilience against manipulated data. Moving on, the interpretability of AI models becomes the next focal point. Maria, a security analyst, expresses her frustration with the black box nature of current deep learning models. She emphasizes the difficulty in understanding and validating the decisions made by these models, which is crucial for forensic analysis and maintaining trust in AI systems. Maria's concern prompts a critical question. How can the team ensure that AI models are transparent and their decision-making processes understandable? In response, Emily highlights the ongoing advancements in explainable AI techniques, which aim to make AI decision-making processes more comprehensible. The team decides to explore XAI tools that provide visual and textual explanations of AI decisions, allowing security professionals to dissect and comprehend the underlying logic. This approach not only aids in forensic analysis, but also in refining models based on human feedback. Considering the relentless evolution of cyber threats, the team acknowledges that AI models must be continuously updated to remain effective. However, they recognize the substantial resource investment required for frequent retraining of models. Mark raises a pertinent issue. How can they efficiently update AI models to keep pace with emerging threats without causing operational disruptions? The group discusses implementing an incremental learning strategy, where models are updated with new data in real time, minimizing downtime and ensuring responsiveness to novel threats. Integration complexity and cost remain significant barriers, particularly for SMEs. Sarah, the company's financial officer, points out the high costs associated with procuring the necessary hardware, software, and skilled personnel for AI deployment. This concern leads to another question. How can cybersecure solutions make AI integration more accessible and cost-effective for smaller enterprises? Emily suggests offering AI as a service through cloud-based solutions, enabling SMEs to leverage AI capabilities without substantial upfront investments. By providing scalable, subscription-based access to AI tools, the company could democratize advanced security measures, making them available to a broader range of organizations. Ethical considerations also take center stage, particularly regarding data privacy and the potential misuse of AI for malicious activities. Maria stresses the importance of ensuring that AI-based security measures comply with legal and regulatory requirements related to data privacy and protection. The team agrees on the need for strict data governance policies and robust oversight mechanisms to prevent misuse and ensure ethical deployment. Bias in AI models is another critical issue that the team cannot overlook. Jason explains that AI models trained on biased data can exhibit discriminatory behavior, leading to unequal treatment of different types of network traffic or users. This prompts the question, what strategies can be employed to identify and mitigate biases in AI models? The team decides to adopt a multifaceted approach, including the use of diverse training datasets, bias detection algorithms, and ongoing audits to ensure fairness and accuracy. Scalability of AI solutions in network security is the final challenge the team tackles. As network environments grow in size and complexity, AI models must process and analyze large volumes of data in real time without compromising performance. Mark raises a crucial question: what technical advancements are necessary to ensure that AI systems can scale effectively? The group discusses leveraging advances in distributed computing and optimization algorithms. By distributing the computational load across multiple nodes, AI models can handle large-scale data processing more efficiently. Additionally, optimizing algorithms for parallel processing could further enhance performance, ensuring that AI systems remain effective even as network demands increase. Emily wraps up the meeting by summarizing their action plan. The team will initiate a pilot study on federated learning, develop robust AI frameworks to thwart adversarial attacks, and integrate XAI tools to enhance model transparency. They will also implement incremental learning for continuous model updates, explore AIS for cost-effective SME integration, and establish strict data governance and ethical guidelines. Finally, they will adopt strategies to identify and mitigate biases and leverage distributed computing for scalability. Through their comprehensive analysis and strategic planning, Cybersecure Solutions demonstrates the potential of AI to revolutionize network security. By addressing data quality, adversarial attacks, interpretability, evolving threats, integration complexity, ethical considerations, biases, and scalability, the team lays a solid foundation for deploying effective and trustworthy AI-based security solutions. This collaborative effort not only strengthens their defenses against cyber threats, but also sets a benchmark for the industry in harnessing the full potential of AI in network security.